In this session, we'll be looking at some past paper questions from CSEC Admaths from June 2022. All right, so we will begin with section 1, which deals with algebra, sequences, and series. So question 1, part A says, consider the quadratic equation qx squared minus 4p times x plus pq squared equals 0, where p and q are both positive integers. So we must pay attention to that. P and Q are positive integers, so we must remember that. And of course, the word positive is highlighted in bold, which means that you're supposed to pay attention to it, right? It goes on to say, express the sum and product of the roots of the equation rather, in terms of P and Q. Now, what do they mean by the product of the sum and root of the equation in terms of P and Q? Now, let's just go back a little bit to talk about the sum and the product of roots of quadratic equations. So while we're looking at the past papers, we're not going to be sticking rigidly to what the past papers require. We're going to go a little bit beyond that to talk about some of the theories behind these questions as well. Now, let's say, for instance, we have a quadratic equation, which of course we know to be of the form ax squared plus bx plus c equals 0. Now, let's divide both sides by a, and so we get x squared plus b over a times x plus c over a equals 0, right? Now, let's say, for argument's sake, the roots of this quadratic are alpha and beta. Now, if the roots are alpha and beta, essentially, when we factorize this equation, we're going to get something of the form x minus alpha times x minus beta, which is, of course, equal to 0. And if we expand the brackets, we'll get, well, x times x, that's going to give us x squared. We get x times minus beta, that's minus beta x. Then we have minus alpha times x minus alpha x. Then minus alpha times minus beta gives us plus alpha beta. And this, of course, is equal to 0. Now, if we simplify and group the terms in x, then what we get is this. We get x squared minus bracket alpha plus beta times x plus alpha beta is equal to 0. Now, if we simply compare these two forms, of this quadratic equation, what do we notice? If we look at the coefficients of x, for the coefficients of x, what we'll see is this. Minus brackets alpha plus beta is actually equal to b over a, which therefore implies that the sum of the roots alpha plus beta is equal to minus b over a, right? So what this basically shows is that whatever the roots are, their sum is equal to minus b over a, where b and a are, of course, the real coefficients of the quadratic equation. B is a coefficient of x, and a is a coefficient of x squared, right? So this is for the sum of the roots. Sum of the roots. Now, in terms of the product of the roots, we see that alpha beta here, if we compare it to this version of the equation, we see that alpha beta would be the term independent of x. And so we see that alpha beta is equal to c over a. And this gives the expression for the product of the roots, right? So this is where the sum and the product of the roots come from, and this is what they're equal to. So for any quadratic equation ax squared plus bx plus c equals 0, the sum of the roots alpha plus beta equals minus b over a, and the product of the roots alpha beta is equal to c over a. Now let's go back to the question. Now the question gives us this quadratic q x squared minus 4px plus pq squared equals 0. Now, if we compare this to the general form of the quadratic, ax squared plus bx plus c equals 0, we'll see that a is equal to q, b is equal to minus 4p, and c is equal to pq squared. And therefore, what this means is that the sum of the roots, alpha plus beta, is equal to minus b over a, which of course will be equal to minus 4p over q, which of course gives us 4p over q. And the product of the roots alpha beta is equal to C over A, which of course would be equal to PQ squared divided by Q, which of course gives us PQ. And that right there is the answer to part 1 of A of number 1. So we managed to find an expression for the sum of the roots and the product of the roots. And we can then now move on to the next part of the question. So let me just clear my screen a little bit and just write down the important answers. So now the sum of the roots is equal to 4p over q. So we can basically say that for the roots alpha plus beta, that is equal to 4p over q, and the product alpha beta is equal to pq, right? All right, so let's move on to part 2 of the question. Now, what does part 2 say? Part 2 says determine the value for q such that the sum of the roots is equal to the product of the roots. So let's read it again. Determine the value of q such that the sum of the roots is equal to the product of the roots. What exactly does this mean? It means that if the sum of the roots is equal to the product of the roots, then essentially we get that alpha plus beta is equal to alpha beta. And so we have 4p over q is equal to pq. And we can then cross multiply and try to solve. Now this time they actually want us to find the value for q. Notice no mention was made of p, but anyways, let's proceed. So if we basically put this over 1 and cross multiply, we get 4p times 1 is equal to pq times q. And so 4p is equal to pq squared. If we continue, we can basically bring all the terms to one side. And so we get 4p minus pq squared is equal to 0. Now, because p is common to the both terms, we can factor out p. And so we get that p, open bracket, 4 minus q squared is equal to 0. Now, whenever you have an equation like this, if you're interested in solving for the two variables, you'd probably go on to say that p equals 0, and or you then now say that 4 minus q squared is equal to 0. So we essentially get our two, well, let's call our two equations. So p is equal to 0, or we can say that 4 minus q squared is equal to 0. But of course, remember we're told that p and q are both positive integers, which essentially means that this p equals 0 is not valid. But of course, we just leave it there for a while, right? Now, let's proceed on to dealing with the next equation. 4 minus q squared is equal to 0, because after all, we were asked to solve for q, right? So this equation we have 4 minus q squared is equal to 0. Now, this we should be able to recognize as a difference of two squares. And so if we have 4 minus q squared is equal to 0, it's the same thing as 2 minus q times 2 plus q is equal to 0. Now, 2 minus q equals 0. That implies that q equals 2. And of course, 2 plus q equals 0. This implies that q equals negative 2. But once again, we're specifically told that p and q are positive integers. So in this particular case, we discard the solution q equals minus 2 and therefore say that q is equal to 2, right? So given the restrictions on q, then q is equal to 2, and that's part 2 of the question worth 2 minutes, right? Now let's move on to the next part of the question. Now part 3 says, if the sum of the roots of the equation is 20, use your answer from A part 2 to determine a value for p. So what they're basically telling us is this. The sum of the roots, alpha plus beta, is equal to 20. And of course, we just found out, or we just determined that the value of q is actually equal to 2. Now let's go back up a little bit and find the expression for alpha plus beta. Alpha plus beta was 4p over q. So basically what we have is this. 4p over q is equal to 20. And of course, you know that q is equal to 2. So what this means is that 4p over 2 equals 20. We divide that by 2, we simply get that 2p is equal to 20, which therefore means that p is equal to 10, right? So therefore, p is equal to 10. And this corresponds to the information given at the beginning that p is actually a positive integer, right? All right, so part 4 now, the final part of this part of the question says, hence, express the given quadratic equation in terms of its numerical coefficients, right? So hence, express the given quadratic equation in terms of its numerical coefficients. So we'll just basically go back up and we'll find the original form of the quadratic and we'll write it down. The original quadratic is of the form qx squared minus 4px plus pq squared equals 0. So we have qx squared minus 4px plus, is it pq squared? Pq squared equals 0. Let me check. Right, pq squared equals 0. So having found the values of q and p, we can therefore say that, well, q is equal to 2. So we have 2x squared minus 4 times 10 times x plus 10 times 2 squared is equal to 0. And so we have 4x squared minus 40x plus 40 is equal to 0. And that right there gives the quadratic in terms of its numerical coefficients, right? For 1 mark. Now, obviously, if we examine the coefficients, 4x squared minus 40x plus 40, we'll realize that those coefficients have 4 as a common factor. So we could simplify by dividing through by 4, but there's no need to do that. We just basically substitute the values of q and p and just leave it as it is, all right? So that's it there for part A of the question. Right. Let's move on to part B. All right, so part B says series is given by. All right, so part B says a series is given by 25 minus 5 plus 1 minus 1/5 plus 1 over 25. And we're told to show that the series is geometric. Now, how do we show that a series is geometric? For us to show that a series is geometric, we have to understand exactly what it means for a series to be geometric. Now, how do we define a geometric series? A geometric series is defined in such as one in which the ratio of consecutive terms is constant. So for a geometric series, the ratio of consecutive terms is constant. What exactly does this mean? For a geometric series, if we take consecutive terms, say t2, and we divide by t1, we should get that to be equal to t3 divided by t2, which should also be equal to t4 divided by t3, which should also be equal to t5 divided by t4, and so on. So if you can basically find the ratio of consecutive terms, and those ratios are equal, then it means that these terms are in geometric progression, or they form a geometric series. Now let's check. In this particular series, the first term, t1, is equal to 25, and t2 is equal to minus 5. So say that t2 over t1 is equal to minus 5 over 25, which simplifies to give minus 1 over 5. Next, we check t3 divided by t2. t3 is equal to 1, and of course, t2 is equal to minus 5, so this of course is equal to minus 1/5. So far the ratio is constant. Next, let's check t4 divided by t3. t4 divided by t3, this will be equal to negative 1/5 divided by 1, which gives us negative 1/5. And again, the ratio is constant. And let's do it one last time. Let's do t5 divided by t4. So t5 divided by t4 is equal to 1 over 25 divided by minus 1 over 5, which of course gives us 1 over 25 times minus 5 over 1, which gives us minus 1/5. And so here we have that the ratio of consecutive terms is constant and equal to minus 1/5, and therefore the series is geometric, right? So having obtained constant ratio, make a statement and say that the ratio of consecutive terms is constant. And therefore, the series is geometric, right? So this basically shows that we understand exactly what it means for a series to be geometric, okay? So that is part one of that part of the question. Now let's move on to part two. Now part two says, calculate the sum to infinity of the series giving the answer to two decimal places. Now, how do we find the sum to infinity of a geometric series? This is a formula. S infinity is equal to A over 1 minus R. Now, this formula is usually given in the list of formulas at the front of the booklet. But of course, in an exam, you don't want to be flipping back and forth to find your formula that you need. So you want to remember these formulas. And of course, if you have practiced enough questions and use the formulas often enough, then automatically you've started to remember them. And you could avoid having to flip to the front of the page to actually find the formula. So the sum to infinity is given by the first term A divided by 1 minus R, where R is a common ratio, which we just showed to be equal to minus 1/5. So in this particular case, A is equal to 25. The common ratio is minus 1/5. So we get 25 divided by 1 minus 1/5. Now minus 1/5, same thing as 0.2. Anyway, this is the same thing as 25 divided by 1 plus 1/5. That would be 6 over 5, or say 1.2. So basically we get 25 over 1.2, 25 by 1.2. Yes, 25 divided by 1.2, and let's see what that gives us. So 25 divided by 1.2, and that gives approximately 20.833. But you're asked to give it to two decimal places, so this gives us 20.83. So this is the sum to infinity of this particular series. Now, what exactly is the sum to infinity? The sum to infinity is actually the value to which the series converges when the number of terms get very, very, very large. In other words, then, as the number of terms approach infinity, then it means that the sum of these terms will actually approach 20.83. That is the significance of the sum to infinity, right? So the sum to infinity, corrected two decimal places, is 20.83. All right, let's move on to the next part of the question and the last part of number one. Now, number one, part C, says a recent university graduate was offered a starting salary of $720,000 for the first year, with increases of $5,000 at the start of every year after. Determine the number of years to the nearest whole number that it would take for their annual salary to be 20% greater than their salary in the first year. So let's analyze this question and write down some important information. So what we're told is that this university graduate is offered a starting salary of $720,000 for the first year. So let our salary for the year one be, let's call that P1 be equal to $720,000, right? Now, also we're told that this graduate will be getting an increase of $5,000 at the start of every year after. What exactly does this mean? So our salary for the first year will be $720,000. In year two, our salary, of course, will now go to $720,000 plus the $5,000, right? That's for year one, year two rather. Now, in year three, she'll get another 5,000. So we can write this as 720,000 plus 2 times 5,000, right? Which of course, same thing as writing out 5,000 plus 5,000. So we write it like this instead. Now, for year four, let's call our salary P4. This would be 720,000 plus 3 times 5,000. And we can do it one more time. We can say that our salary for year five would be equal to 720,000 plus 4 times 5,000. So by now, we should start to see a particular trend for her salary at a particular year. So we can basically take a general formula and we can say that her salary after any years would be equal to the salary in year one, which is basically 720,000 plus n minus 1 times 5,000, right? Because of course, her salary in year 5 would be 720,000 plus 4 times 5,000. Her salary in year 4, 720,000 plus 3 times 5,000. Her salary in year 3, 720,000 plus 2 times 5,000. And we consider the salary in year 2 would be 720,000. I guess we could probably put this times 1 to show the trend, right? And that's our trend. And so generally, what we say is that her salary in the nth year will be equal to 720,000 plus n minus 1 times 5,000. And this, of course, should resemble an arithmetic progression. Remember, for an arithmetic progression or an arithmetic sequence, the nth term, Tn, is given by the first term A plus n minus 1 times the common difference D. And exactly what this is. So these terms are in arithmetic progression. Okay? All right, so let's proceed to what the question actually asked us now. It says, determine the number of years to the nearest whole number that it would take for her annual salary to be 20% greater than her salary in the first year. So her salary in the first year, P1, is equal to 720,000. Now, if after a certain year, say after n years, her salary is going to be 720,000 plus 20% of 720,000. And this, of course, is the same thing as 1.2 times 720,000, right? When you add 20% of something to that same thing, essentially you're multiplying by 1.2. If it was 30%, you're multiplying by 1.3. If it was 40%, you're multiplying by 1.4, and so on. So let's go to our calculators and see what that gives us. 1.2 times 720, that gives us 864. So therefore, say that our salary at the nth year would be $864,000, right? Now, if we substitute this into a little formula that we have from over here, we will see that 864,000 is equal to 720,000 plus n minus 1 times 5,000. And we basically proceed to solving for n. So we bring the 720,000 across to the other side. We get 864,000 minus 720,000. That is equal to n minus 1 times 5,000. And so what this gives us, 864 minus 720, that looks like 144,000. So we have 144,000 is equal to n minus 1 times 5,000. And if you then divide both sides by 5,000, then the 5,000 over here, divide by 5,000 over here, these two will cancel. And so we get 144,000 divided by 5,000 minus 720 divided by 5. This gives us, is that, oh, let me check something. 864,000, 864,000 minus 720,000. Right. So 144,000, right, then divided by 5,000. Right, so this gives us 28.8. So 28.8 is equal to n minus 1, which implies that n is equal to 28.8 plus 1, which further implies that n is equal to 29.8. So 29.8, then obviously that corresponds to the 30th year. So therefore, n is approximately equal to 30. So therefore, she will be getting a salary of approximately 20% of her first year salary in the 30th year of her employment. All right. So that is the end of question 1 of this paper. This is actually 2022. And so we'll now move on to question 2, which of course is the second question in section 1 of the exam. Right? So let's look at number two. Number two deals with polynomials and things like remainder theorem, factor theorem, and so on. So let's read the question. A key part of being successful in any exam is to read the question carefully, right? So don't be rushing to answer the question and not read the question properly. So it says when the polynomial expression 2x cubed minus 3x squared minus cx plus d is divided by x plus 1 and x minus 2, the same remainder of 64 is obtained. They actually, there's a little typographical error here, OBATINED, but anyways. So they are OBATINED as opposed to OBTEINED, right? So yes, it says determine the value of C and D. Now let's write down our polynomial and let's call our polynomial f of x. So f of x is equal to 2x cubed minus 3x squared minus cx plus d. Now what are we told? We're told that when this polynomial is divided by x plus 1 and x plus 2, the same remainder of 64 is obtained. Now how do we express that in terms of an equation? If we take x plus 1 and we set it equal to 0, then this means that x is equal to minus 1. Similarly, if we take x minus 2, we set it equal to 0, then this gives us that x is equal to 2. Now, according to the remainder theorem, the remainder when f of x is divided by x minus a is given by f of a. Let me write that down. So according to the remainder theorem, the remainder, let's call it R, when a polynomial f of x is divided by x minus a is given by f of a, right? So what this basically means is that the remainder when this polynomial is divided by x plus 1 is given by f of minus 1. And similarly, the remainder when the polynomial is divided by x minus 2 is given by f of 2. And since we're told that both yield the same remainder of 64, it means that f of minus 1 equals f of 2, which actually equals 64. So let's apply those individually. So we can say that f of negative 1 is equal to 64. And so we say that 2 times negative 1 cubed, because remember, this of course is our polynomial. Polynomial is f of x equals 2x cubed minus 3x squared minus cx plus d, right? So we say that 2 times negative 1 cubed minus 3 times negative 1 squared minus c times negative 1 plus d is equal to 64. So we'll simplify this and we'll get our first equation in C and D. Now minus 1 cubed, that is minus 1. Minus 1 times 2, that's negative 2. Minus 1 squared, that is 1. 1 times negative 3, that's negative 3. Then minus c times minus 1 is plus c. And we have plus d is equal to 64. And so we have minus 5 plus c plus d is equal to 64. And therefore, what this means is that c plus d is equal to 64 plus 5. And the first equation is c plus d is equal to 69. So let this be equation 1, right? Now, we're also told that the remainder when the polynomial is divided by x minus 2 is also equal to 64. And so therefore, what this means is that f of 2 is also equal to 64. And so we have now, the polynomial of course is 2x cubed. So we have 2 times 2 cubed minus 3 times 2 squared minus c times 2 plus d, and that is equal to 64. All right? So let's simplify this. Now 2 cubed, that is 8. 2 times 8, that is 16. 2 squared, that is 4. 4 times 3, that is 12. So 16 minus 12 minus 2c plus d is equal to 64. Now 16 minus 12, that gives us 4. So we have 4 minus 2c plus d is equal to 64. We can bring the 4 over to the right-hand side. And so we get that minus 2c plus d is equal to 64 minus 4. Or we can say that minus 2c plus d is equal to 60. And of course, we can call this our equation 2. So now we have two equations, which will, of course, solve simultaneously. We have minus 2c plus d equals 60, and we have c plus d is equal to 64. That was equation 1. Now, simply, if you were to subtract these two equations, the d's will disappear. So let's subtract equation 2 from equation 1. Now, subtracting equation 2 from equation 1, what we're going to get is this. C minus minus 2c, so we have c minus minus 2c plus d minus d equals 64 minus 60. So what we have here is c plus 2c. These cancel to give us 0, and that's right, plus 0 equals 4. So we have 3c is equal to 4, which means that c is equal to 4/3, right? And having found, c plus d equals 64 minus 2c plus d equals 60. Let's try to do c minus 2 minus 2c, that's c plus 2c, 3c equals 4. All right, so c is equal to 4/3. And if you substitute that into one of our above equations, c plus d equals 64. So c plus d equals 64, which means that 4/3 plus d equals 64. And so d equals 64 minus 4/3. We can write 64 as, let me see, 64 times 3, that is 180 plus 12, that's 192. This is 192/3 minus 4/3. And so d is equal to 188/3. Strange looking numbers, but they look correct. Alright, so therefore c equals 4/3 and d equals 188/3. Is that all that they wanted us to do? Yes. So for this part of the question, that's all we're required to do. Find the value of c and d. And so we see that c is equal to 4/3 and d is equal to 188/3. Now, many times when students are doing questions and they get numbers like these, for some reason, they're convinced that they must have made a mistake. Because for some reason, they think that, hey, I should be getting a nice integer. No, the questions are not always designed for you to get an integer. So as long as you're confident that what you actually did is correct, and if you go back and you check your working and don't find any mistakes, then of course, just leave it as it is and proceed. Okay? All right, so that was part A of the question. Now, let's look at part B. No, actually, before I move on, let me just check to make sure I did not make any mistake, right? So yes. So f of x equals 2x cubed minus 3x squared minus cx plus d. We're told that when the remainder, when it's divided by x plus 1 and x minus 2, the remainder is 64. X plus 1 equals 0, x equals minus 1, x minus 2 equals 0, x equals 2. So this means that f of minus 1 equals 64. So 2 times minus 1 cubed minus 3 times minus 1 squared minus 3 times minus 1 plus d equals 64 minus 2 minus 3 plus c plus d equals 64 minus 5 plus c plus d equals 64, c plus d equals 69. That looks correct. F of 2 equals 64, 2 times 2 cubed, that's 16, minus 3 times 2 squared, that is minus 12, minus c times 2, that's minus 2c plus d equals 64. So 4 minus 2c plus d equals 64, minus 2c plus d equals 64 minus 4, minus 2c plus d equals 60. Second equation, c plus d equals 64. Subtract both of them, right? C minus minus 2c, that gives us 3. C plus 2c plus d minus d equals 4. Looking correct, yes, looking correct. All right, yes, so now we check that. Let's move on to the next part of the question now. All right, so the next part of the question says, let me just clear the screen a little bit. Next part of the question says, show that the expression root 25 over root 45 is the same as root 5 over 3. So what does this require? This requires our knowledge and properties of surds, right? So we need to apply our knowledge and the properties of surds to this particular question. All right, so let's recall some of the laws or the properties of surds, right? So based on some more properties or laws of surds, we remember that, for instance, root AB, same thing as root A times root B, root of A over B equals root A over root B, and of course root A squared simply just equal to A. Right? So those are some of the properties of surds. And of course, occasionally we may need to do what is called rationalizing the denominator of a surd. Surds are generally, are irrational numbers. And so when you say we're rationalizing the denominator, that means to make it rational. In other words, make it a rational number. All right, so let's look what is happening here. We have root 25 over root 45. So root 25 over root 45. Now, clearly, 25 is a squared number. So root of 25 is just as equal to 5. So this becomes 5 over. Now, when we want to simplify surds, like for instance, a number like 45, we first express that number as a product of two numbers, one of which is a squared number. What exactly does this mean? We can multiply different pairs of numbers to get 45. 1 times 45 gives us 45, but writing it as 1 times 45 does not help us. We can also write it as 3 times 15, but none of those is actually a squared number. So what's the next pair? We can write it as 5 times 9, and of course 9 is a squared number, and so this becomes root of 9 times 5. And from the laws of surds, the first one in particular, is of course the same thing as 5 divided by root 9 times root 5. Of course, 9 is a squared number, and so therefore this becomes 5 over 3 root 5. Now that we have gone this far, we have a surd in the denominator. And if you notice in the result that it wants us to show, there is no surd. So what we'll have to do is to rationalize the denominator of this expression, and we do so by multiplying both numerator and denominator by root 5. And so this gives us 5 root 5 divided by 3 root 5 squared. And of course, root 5 squared is the same thing as 5. So I could take this off and continue over on this side. So basically, this gives us 5 root 5 divided by 3 times 5. We divide, then this 5 will cancel this 5, and so this leaves us with root 5 over 3, which of course is what we're desired to show in the first place. So we've managed to prove that, okay? All right, let's move on to the next part of the question. The next part of the question says, given g of x equals 6x squared plus 12x minus 18, express g of x in the form a, open bracket, x plus h, close bracket, all squared plus k. Now, whenever we're told to express a quadratic in this form, what exactly are we being told to do? Essentially, we're being told to complete the square, right? We're being told to complete the square, and in order to complete the square, the coefficient of x squared must be 1. So let's begin. So let me write down g of x. So I'm going to say that g of x is equal to 6x squared plus 12x minus 18. Now, what is the coefficient of a, or what is the coefficient of x squared rather, which of course is deemed a in this quadratic? Now, remember that any quadratic is typically of the form ax squared plus bx plus c. Now, in this particular case, we see that a is equal to 6. And because a is equal to 6, we cannot proceed to completing the square because a must be equal to 1. So what do? We say that we're going to factor out 6. So we're going to say that g of x is equal to 6. And I'm going to open a square bracket. And this leaves us with x squared plus 2x. I'm going to leave some space inside there. And I'm going to leave the minus 18 over here by itself. So there's no need to actually factor out 6 out of the entire quadratic. We can just factor it out of the first two terms, and that is perfectly okay, right? I left some space inside the square bracket because, of course, I will have to add some terms in order to complete the square. Now let's focus on this quadrant that is now inside the brackets. Now we see that A is equal to 1 and B is equal to 2. So A is equal to 1 and B is equal to 2. In order to complete the square, I must add a half of B squared. Let me repeat that. In order to complete the square, I must add a half of B squared. Now B is equal to 2. Let me just write it down to the side here. B is equal to 2, and therefore half of B over 2, equals 2 over 2, which is equal to 1. So in order to complete the square, I must add plus 1 squared. But by doing that, I will change the overall quadratic. So therefore, to prevent that, I must also subtract 1 squared. Okay? So this is an integral step in completing the square. Because when you're completing the square, you're essentially making a part of the quadratic a perfect square. And in order to do that, you must add a half of b squared. In other words, you must add b squared over 4. That is what is necessary to make it a complete perfect square. Now, having done that now, then this little piece right here, these first three terms will form what I call my perfect square, right? The first three terms will form my perfect square. So I can proceed to write down this. I could write now g of x equals 6. I still have my 6 outside. And then my perfect square inside is going to be now x plus 1 all squared, right? So this plus 1 that I added is actually what comes here. So let me try to indicate with the particular color. So this plus 1 is what comes here. So we have x plus 1 all squared, right? And that, of course, is a perfect square. And outside, I still have my minus 1 squared, of course, is minus 1. I close my bracket, and I have my minus 18 outside. So I just use a color to show you where those numbers came from, right? So I will just expand now by multiplying through by 6 and then simplify. So therefore, this gives me g of x is equal to 6, open bracket, x plus 1, close all squared, minus 6 minus 18. And so I have g of x is equal to 6 times x plus 1 all squared minus 24. And of course, we're told to express it in the form a x plus h all squared plus k. So we can now say that g of x is in this form. G of x is equal to a, open bracket, x plus h all squared plus k, where a would be equal to 6, h is equal to 1, and of course k is equal to negative 24. So those are the values of a, h, and k. Now, what is the significance of completing the square? Let's see what else it asks us to do. So they say now, use the expression derived in C part 1, determine the roots of g of x. Now, before we move on to that part, when you complete the square, what can you actually determine from the completed square version, of the quadratic? Once a quadratic is in this form, you can actually write down the turning point of the quadratic, right? Now, because we're told to put it in this form, a, x plus h all squared plus k, what this means is that the turning point is minus hk, right? So the turning point is minus hk, which of course would be therefore equal to minus 1 minus 24. So this is what we can actually determine after completing the square of a quadratic. We can actually just write down the turning point. Now you have to remember that the x-coordinate of the turning point is essentially the value of x, which makes this expression equal to 0. So inside here we have x plus 1 squared. If you set x plus 1 equals 0, then that gives you x equals minus 1. And so therefore the x-coordinate of the turning point is minus 1. And this value over here is, of course, the y-coordinate, minus 24. So hence, the turning point is minus 1, minus 24. All right? Now, let's go back to see what the next part of the question says. It says, using the expression derived in C part 1, determine the roots of g of x. So, let's write down g of x in the form we obtained. G of x is equal to 6, bracket, x plus 1 all squared minus 24. All right? So when you want to find the roots of g of x, then of course it means that g of x is equal to 0. So we set g of x equal to 0, which means that 6x plus 1 all squared minus 24 is equal to 0. And so we say that 6x plus 1 all squared, we can bring the 24 across, it's going to change sign, become a positive 24. And then, of course, you can now divide both sides by 6. Dividing through by 6, we get x plus 1 squared is equal to 4, right? So x plus 1 squared is equal to 4. Now, many students, when they see an equation like this, they're just focusing on positive numbers. But you have to remember, when it comes to expressions like this, you have to take both the positive and the negative square root. So what we say is this. We say that x plus 1 is equal to plus or minus the square root of 4. And so x plus 1 equals plus or minus 2. And we take turns and we solve for x. So in the case, we have x plus 1 equals 2, which means x is equal to 1. Or we have x plus 1 equals minus 2, which means that x is equal to negative 3. And therefore, these are our roots of g of x. Okay? These are our roots of g of x. Now, the question does not ask for this, but this is a little property that students should know. Now, let's do something with these two values. Let's look at the two roots. X equals 1 and x equals minus 3. So, let's look at this. Minus 1, sorry, it's actually 1 and minus 3, not minus 1. So, let's look at this. So, we have minus 3 plus 1 divided by 2 gives us minus 2 over 2, which actually equals minus 1. And what is the significance of this minus 1? This minus 1 is actually the x-coordinate of the turning point. So this is always going to be true of the roots of a quadratic. When you find the roots of a quadratic equation and you average them, then you ought to get the x-coordinate of the turning point. Because remember, whenever we find the turning point of a quadratic, it essentially forms what is called the line of symmetry or the axis of symmetry. And what this means is that the line through the turning point will divide the quadratic into two halves. In other words, then, the quadratic is symmetric about this line of symmetry, which passes through the turning point. So that is why the roots are always going to average to give the axis of symmetry, due to the fact that the graph is actually symmetric about the turning point. Okay? Yes. All right. So having said that, let's see what the next part of the question asks us. All right. So they tell us to sketch the graph of g of x on the following grid. Now, when it comes to sketching the graph of a quadratic, we need few things. Let's jot them down. We need, one, to know the nature of the quadratic. What exactly does this mean? We want to know if it's going to be a smile or it's going to be a frown, right? In other words, if it opens upwards or if it opens downwards. And how do we do this? Typically, when a is greater than 0, it opens upwards, or we say it's a smile. When a is less than 0, meaning negative, it of course opens downwards, right? However, in this case, we're given that a is equal to 6. So we know that it's going to open upwards. So we know the shape. Good. 2. And these, of course, not in any particular order. The y-intercept. The y-intercept. The y-intercept, of course, occurs when x equals 0. So this, of course, obtained by evaluating f of 0. And if you look at the original version of the equation, we see that g of x is equal to 6x squared plus 12x minus 18. And clearly, g of 0 is equal to minus 18. So therefore, the y-intercept is minus 18. So g of 0 is equal to negative 18. What else do we need? We need the roots. And of course, we know the roots are x equals minus 3, x equals 1. We found those. X equals minus 3, x equals 1. And of course, we want also the turning point. And we already found the turning point, which of course is -1 minus 24. So with all that information, we can now go ahead and sketch our graph as best as we possibly can. All right, so we need the graph to go all the way down to -24, and the y-intercept is -18. So that means you're going to have quite a few values down on the negative y-axis. All right, so let's see now. Let me put my y-axis. Let me just draw a line here. And of course, in terms of our x values, we need to go as far as -3 and 1. So we need some values to the left. So let me put my axis in the middle. This is 1, 2, 3, 2, 4, 6, 8, 10, 12, 14. Can't even count these things. 6, 8, 10, 12, 14, 16, 9, 3, 4, 6, 8, 10, 12. So that's my y-axis there. All right, so let me see now. I have to try to choose a scale, so I got my negative values down here. So I need to go down to as -24. What scale do I use? Let me see. Suppose I make this -24 and -20. No, that's not enough good. What we put here? -20. No, I'm gonna try -25 minus 25. -30, -30, -20, -10, 0. All right, I'll call it this. So this will be -30. This will be -20, -10, 0. Right, let's do it like that. This of course is 10, this is 20. Right, let's do it that way. This is not going to be my x-axis. Right, my x-axis. To make it symmetry. Alright, so that is my x-axis. I need -1, -2, -3. So -1, -2, -3, -4, -5. And then 1, 2, 3, 4, 5. All right, so my y-intercept is going to be -18. This is -10. This will be -15. 16, 17, 18 will be right here. That's my y-intercept. The roots are at x equals -3, x equals 1. So -3 right here. X equals 1 right there. And of course, my line of symmetry is true. X equals -1. So this is my line of symmetry here. Right, that's my line of symmetry. And of course, my turning point is -1 minus 24. So -1 minus 24 is going to be down here. This is -20, -24 would be right here, right here. Right? All right, so now I can actually go ahead and sketch my quadratic. All right, so it's going to look something like this. My turning point. Right, not perfect, but I mean, it's not perfect, but you get the idea. Right, so something like that, right? So it's not perfect, but at least we show the main features. We show the main features. Right? So yes, that's our project. Let's label our important points. Our important point right here is our turning point. This point right, this point right here, just label it. So this point right there would be -1 minus 24. That's our turning point. And this is our axis of symmetry. x equals -1. All right. So if we do all of that, then of course you should get the 3 marks for this sketch. And of course, this brings us to the end of this question and the end of this section from May, June 2022, paper 2 of CSEC Admaths.